Hello everyone, and in this tutorial we will take a look how can we make sure that there are no intersections between copied point geometry. At the end of this tutorial we should have net for something like this, and if I go ahead and move some of these, change some of this geometry, our copied points should move away and there should be no collisions between this, and also no collision between each copied point geometry. So you see our geometry is very different from each other, and that can be a challenge for us to not make sure that there are no intersections. So that's what's on the agenda today. We will use a little bit of a Vex code, but that's nothing too serious, and that's it. Let's get to it. Let's start by creating a grid, and I'm going to make it 30 by 30. And let's make a little bit more of a resolution for it. Let's make it also 30. Something like this. And now let's create some cutout geometry. That's going to be our collision. So I'm going to poly extrude this. So something maybe just the one, and let's not output front, just the sides. And let's extrude it again. Let's output all of it. And let's output it. Let's output actually maybe inwards like that. So this could be our borders of our geometry. And now let's create some boxes. So let's template this. Let's go to the top of it. Let's scale it up. Let's copy it. Just 2 boxes. Something like this. So this is going to be our collision geometry. So let's merge all of these together. And this is going to be our point geometry. So let's make sure that these are actually, well, it doesn't have to intersect necessarily, but they should be in the proximity of a grid. So our collision geometry is done. Now let's put in array node and we want to create some collisions. So put down array node, make sure that it's at the minimum distance, turn off the transfer point, and turn on the create point group. Call it to del PTs. So this is going to be a point group. It's going to be within the range of our minimal distance. So let's put it at 1 and let's take a look at the group. Let's turn on the visualizer group so you can see. And how it works, it's just basically all of these our points, our grid points are going to try to find the nearest primitive surface of this geometry, and you can see it finds it very nicely. So these points, you can increase it and you're going to select more of it. So let's do it by 1, but we have one problem, is that it's everything inside here, where there's basically these points cannot get to the surface of our collision geometry. We should also include them, and for that I'm just going to put down a group node. I'm going to, group name is going to be our existing to delete PTs. We do not want to replace it, we want to union with the existing, so we are just going to add to this existing group, and that's going to be a point group. And all I'll do is in a group node feed our collision geometry inside it, and inside here base group, disable base group and keep by bounding regions and select a bounding object, which is our second input. So you can see all the points within the bounding box of our collision is also included. This is exactly what we want. And also let's put down the mountain slope for our grid. So let's make it a little bit more of a like a terrain. So just a little bit. let's make it a little bit element size, something like this. So it's maybe a little bit more natural looking, like that. Since when we're going to start to copy these points, it's maybe gonna look a little bit more natural. So, okay, so, and all we have to do is now delete them, delete the points. So put in a last node and just select the to delete points and make sure it's not delete non-selected, like that. And you can see there are some unused, basically points that are not connected to anything. We can just put down a clean node, and by default options, if you put it inside here, it should very nicely clean up. So that's that. This is going to be where we can spawn our points to. And now let's get our geometry. So I just went to the Quixel Megascans and got a couple of geometry files. So there they are. They're just a couple of, I just took same theming of the like Roman columns and something like that. Something like with the different scales and different widths so that we can avoid collisions. So just get some geometry that you want, and I just this geometry just came in with the app that says that export to Houdini. So we're gonna have to do a little bit of a processing for it for us to successfully scatter it. So let's go ahead inside our network and let's put in an object merge. And let's get all of our geometry, because now the geometry sits at the object level. Let's get it to the geometry level. So go ahead and start selecting. And what's cool about this, every one of these imports are actually going to be a geometry containers. Are actually going to be called asset geometry. So you can just filter it by asset and it's going to give us all of these. So start by selecting all of them. There's this and the last one. So we have now imported it, and you can see there's a couple of artifacts right now. They are, the color has been a little bit of a, there's a little bit problem with the color. So what you can do is actually attribute delete the color attribute. That's going to be a vertex, like that. So there's no colors. So, okay, we have our geometry. First of all, the geometry is pretty heavy. We can, to copy the points, we can either instance it, but for our method to detect the collisions, we actually want to copy more of a more representative shape of the whole geometry. So what I'm going to do is actually put down a labs bounding box node. I'm going to run through this geometry and create a proxy geometry that's going to be represented by the bounding box of this. Then we're going to copy it to the points, and then we're gonna extract the points and copy the instance geometry back to those points. So basically we don't want to work on all of this geometry because it is very heavy, and if we do not instance it, it's going to get really slow. So let's start by working on this. So for our differentiating attribute, you can see that there is a name. So there should be a unique name for all of these imports from the Quixel Megascan. So this is going to be, we're going to use it as a unique identifier when we run through it. So put in a for each, let's call it a name primitive. And as an attribute, as a piece attribute, let's put it as a name. As you can see, by default, this already should be, because name is a primitive attribute. You can see the names is basically LODs and all of that. So let's put down a bounding box like that, and we can keep it like that or even lower resolution, one by one, like that. Merge it, but the problem now is we do not have any attributes. So I do want to, for this, I just want to give it a unique identifier as a ID identifier. So what I'm going to do is actually, before we create our bounding box, we're going to give the real pieces of geometry a unique identifier. So let's just I just copy it again, put it inside here, and instead of bounding box, put down a wrangle, create meta import node, and this is going to be our counter. So select this and create a spare input on this one, on this, so that we can, well, actually it's a wrangle node, we can just connect it inside here, and then just create a, let's create a primitive attribute. So e at, I'm gonna call it a prop id equals, so that's going to be our iteration number. So detail, that's going to be 1, iteration, that's going to be 0. I think it's like an index or something. And that's it. Merge together. You can see, go to the primitives, prop ID. Every one of these props should have a prop ID. And we actually, let's use our prop ID to run through this one. Not the name, but prop ID. Like that. So it shouldn't really change anything. And let's get our prop ID also on our proximity geometry. So attribute transfer, click inside here and connect the incoming from the loop geometry. And the only thing that we want to get is our prop ID, like that. Check it out. There's a primitive prop ID, and that's it. This is really the only thing that we're going to need for our proximity geometry. Take a look at the result. The prop ID should work. Okay, so that's good. Let's create some output. So let's put a null. Let's call it out proxy geo. Let's call it something like a purple. And let's copy it. Oh, just a null. And let's call it prox out. Let's call it f out prop geo. Something like that. And now let's scatter some points across our geometry. So put down a scatter. Actually, let's put a scatter and align node. And this node is very nice for us to get just the initial scatter across the geometry. So easiest way is just put it down after the clean node, and with the coverage we can just increase the coverage, and that's it. So this scatter and align node does like to change the p scale of the geometry, and you can see it's actually going to create a p scale, which basically controls the uniform scale of our copies that we're going to copy geometry to. So just make sure that if you do it by size and you do not change the uniform scale, you can see that this p scale won't be affected. So just make sure that it is at 1, because my geometry is lifelike size and I do not really want to make it smaller or bigger, so it should be uniform scaled, copied. And I'm just going to change the coverage, maybe something like this, and let's just take a look at copy to point, and let's take a look at the results. Before I'm going to connect these, I actually want to now create an attribute adjust integer, because we have a prop ID on this geometry as a primitive attribute, and I want to make sure that I have the same attribute also on these points, so that it doesn't copy the whole geometry on every point. So go to the attribute adjust, put down a name, so that's going to be a prop ID. So set always, random, and min max. We know we have a three points of geometry, so from 0 to, actually we have 4, so with 0 it's going to be 4, 0 to 3, and we should find our prop ID. There it is, and then just connect it to the points to copy to, like that. And for the piece attribute, prop ID, and that's it. So you can see we are already copying them, so there is no, we need some random rotations. So go to the scatter and line, rotation around the normal. Make sure that it's at 360 degrees, like that. Let's actually make coverage a little bit smaller, maybe something like this. And so this looks good. And also we can put down some normal cone angle, which basically, so before this, at the clean node, let's take a look at the normal. You can see we have some, by default, there's going to be some vertex normals. But once you go to the scatter and align, it's going to become a point normals, and it basically has inherited the vertex normal. And if you want to make a little bit more of a kind of a natural look, you can actually just rotate them a little bit so that they go on the sides a little bit, so that maybe if it's on the surface, so that it has with time and they have skewered a little bit around. So that's good. So this is our copy geometry. You can see even though this geometry is pretty nicely copied, there are some intersections. So one way for us to not to have these intersections is basically put down this coverage to very small, something like this, which still looks pretty alright. But let's say you have some intersections with the 0.7. So let's say we like this geometry, and also we have to make sure that it doesn't intersect with this one. So let's take a look at it. So you can see we have a couple intersections also inside here with this, and also with the copy geometry. So basically we want to just clean this copy to points so it doesn't intersect with our collision geometry, which is going to be a static, and with the copy to points geometry, which is these. What we want to do is create a wrangle node, and we are going to give a new attribute for every one of these points, and we're going to call it an ID. So there's going to be a unique ID for every one of these points. And what's good about that is because once we have copied geometry to these points, the geometry that was copied also going to inherit this unique ID. So then we can just calculate the intersections, and if even one of the IDs are in the intersection group, we can basically delete all of them from that. So let's go ahead to the wrangle node. Let's call it integer at ID equals at ptnum. So we are giving the point number as a ID for it. So you can see, go to the points, and the ID is same as the point number inside here. And if you go to the copy to points, go to the points, you can see we have now IDs for every one of the geometry, for every point of the copy geometry, unique ID. So this is exactly what we want. And now let's calculate some intersections with geometry. Let's start by deleting any intersections with our static geometry. So I'm going to, from our merge, let's pull these down, something like this. Let's go to our copy to points, and let's put down a boolean node. And the boolean, let's connect these, our copy today, the B as a boolean, and the operation, select the operation as detect. And we just want to detect intersections. So what's cool about this, we can detect intersections with A and B polygons, basically this geometry with this one. Let's go ahead and select it. And you can see, if you go to the group visualizer, you can see, let's template this one. You can see we are selecting, the group has selected all of these as a detection. So we just want to remove these. And let's do that with a little bit of a VEX code. Let's rename our group. Let's make it 2 del prims, so that we know that we want to delete them. And one thing that we have to do is actually convert our ID attribute from our boolean, from our copy to points. So right now they are the point attributes, our ID, but it's going to be a little bit easier for us to actually convert them to the same type as our detection group, which is a primitive. So put down attribute promote, and let's promote our ID to the primitives, like that. So put down a wrangle node and run through the primitives. And what's good about this, we can actually already eliminate biggest vast part of this geometry by not running through it, by selecting the group, which is the to delete primitives. So this is going to run only through these primitives that are inside here, that are actually in a group to delete prims. So that's very nice. And I'm going to open this up inside external editor. Let's write some code in it. So first of all, we want to get our ID of that primitive that we run through, which is now it's going to be a primitive attribute. So let's do that. Integer, I'm going to call it ID equals prim. Attribute name is ID and prim num is at prim num. So now we get our ID, and we know that this ID is already marked for us to delete. So if I want to get all of the members of that ID, all of the primitives that are the members of that ID. So what we can do is actually use expand prim group. So, and for the expand prim group, it's actually a really nice function. Let's open it up inside here, inside help, and in expand prim group of X functions, we can actually use the ad hoc groups like 0 to 3, or we can basically point to the attribute and say that we should select only attributes as a group only that has that value. And we can actually use this to select all the members of that ID, get the array of them. So this is what we're going to use, this kind of a styling to get all the members of the same ID. So that means we're going to have to concatenate some strings. So we have to give it a string. So let's create a string. So let's call it a group expression, and make sure that, so if you think about it, we want to get our at ID equals, and since we have to add two strings, we can actually use add sign, and all we have to do is convert our ID to the string, and there's a function for it which is e to a, and give it an ID like that. And now let's create an array. Let's call it 2del array, and make sure there's square brackets for it. Equals to expand prim group, geometry 0, and group name is going to be our group expression, like that. So this is going to give all of the members of the same ID primitives, and all we want to do is do a for each loop, because it's an array. So item is going to be integer prim, and array is going to be 2del array, and all we want to do is remove primitive. Remove primitive number is going to be prim, and also we want to delete the points. So that's going to be basically it's an integer 0 or 1, and we also want to delete the points, so that's 1, yes. And that should be it. And let's take a look at it. You can see we have these 3 intersections, and after this node, you can see they are gone. So this is how we have taken care of intersections with static geometry. And let's take care of the intersection between the copy geometry. The most easiest way for us to actually take care of all the intersections, I'll just copy this network, and go to the Boolean, and also detect A and A polygons. So select this, and just give it the same name as to delete prim also. It's actually going to combine these two groups together like that. And if we go to the very end of it, you can see it basically has fixed all our overlaps right now. The one drawback of this is actually that it's actually going to delete all of these. Basically, the best case scenario, we should probably try to keep maybe this one and also this one, because these two can exist without intersecting each other polygons. But obviously with this group, we are deleting all of them. So this is the easiest way for us to delete all of the intersections. But I'm actually going to show you how can we actually loop through this geometry and actually delete the intersections without with basically leaving some of this geometry intact. So this is one method to do it. I'm going to delete it, and we're going to actually run a for each loop. And start by putting down a for each number loop, And for each number, we're basically going to feed this geometry a number of times, and we're basically going to process it and move it back to the top of it and do it again. So for this, we want to do a fetch feedback, and for the end block, we want to do feedback each iteration. So this goes, we are just sending geometry from top to bottom and back on. And the number of times that we're going to actually do it is going to be at the worst case scenario, we're going to run it through the amount of IDs we have. So this is going to be 87 times. So most of the times it's not going to do anything, this loop, but we have to make sure that every primitive ID is checked. So that's going to be 87 times. And so basically we have deleted some of the IDs inside here. So some of these loops are going to be empty, but the worst case scenario, we can have to check every one of these. So let's put down a min-max labs node, and we get the max value of our ID. So put down a max. This attribute is going to be a point attribute. Actually, it's a primitive attribute, and the ID. And if you go to the details, you can see actually not the average, but the maximum. You can see we have 87, and this is the amount of times we want to loop through. So let's go to our block begin block end, and this attribute is actually going to be persistent through this loop. So we can actually go to the iterations, and I'm going to use my toolkit for me to easily paste this attribute. I'm going to max ID. I'm going to set it to 87 like that. So this is just expression. You can write it out or use my toolkit from the GitHub. Go ahead and download it for easier pasting of the functions. So we are now running 87 times. Now let's detect intersections with single polygon with it. So I'm going to turn off this template, because we are right now we are going to run only through the copied points. We are not going to run through the static intersections. We have already taken care of them. So let's do that. Let's put down a Boolean node, and let's connect both of these to the both set A and B, and we are going to separate our geometry with the groups. So we want to get for our A, we want to get only the single ID geometry. So that's going to come from our counter node, because the only thing that in this loop is going to change is our geometry that we're going to feed back on top of it, and also our counter node, which is this one, which is iteration. So we want to make a connection between a Boolean and the counter node, and you can do that by go ahead and adding a spare input like that, and just copy this one inside here. So this is, and automatically it's by Houdini is going to be automatically set up as a connection. And now you can use functions. You can use expressions functions and refer to this counter node and get attributes from it by referencing a -1. But I'm actually going to show how can you do it easier with my toolkit. I'm going to go ahead and remove this parameter. If you want to easily set a relationship between two nodes with the spare inputs, select the node that you want to reference, select a Boolean with a shift, go ahead to my toolkit and add spare input like that. It's automatically created. So that's that, and let's set our groups. So for the group A, I want to add ID, and another reason why we made this group a primitive is because the Boolean node actually expects only primitive groups for the Boolean node. So equals, and now I'm going to also use my toolkit to get some get geometry attribute, which is a detail. Accept it, and we know it's called iteration. And we want to append to it. Append -1, which is our spare input reference, like that. You can see it's already working, and what we'll do is for our set B, we want to do everything except for that geometry. So paste inside here, and the ID is going to be we can paste it, and before that we can give it a star, which means all of the geometry, and then the caret except for the ID geometry, this one. Basically we have inverted the group like that. And for actual deletion, let's go to the, instead of subtract, we want to detect, and let's use the same 2del prims, and we can actually reuse this code. So copy it and paste it inside here. Make sure it's connected. The group name should be the same, and that's it. Let's take a look at it. So we should be now fixing all of the intersections between the geometry. Let's take a look at it. Before, as you can see, we have a bunch of intersections. Right now, there's basically none of it. And it should look a little bit better than we have done it inside here. So let's take a look at how it would look like if you had deleted all of them also inside here. So you can see it has deleted. So inside here where we delete all of the intersections, you can see it has taken out a lot more geometry out of it. But with this method, it's actually, we have preserved a lot of the long pieces, which are most likely to actually intersect with other geometry. So this has taken care of intersection logic, and actually this is a lot easier than the my first method, which used actually a lot of Xcode. So this is very simple way to do it. And let's say for now we want to also delete it by the proximity. So let's say we are creating a game environment and want to make sure that there are places between these objects that we can actually walk through. So even though intersections are fixed, we actually want to make sure that we can actually walk through some of these environments. So what you can do is actually reuse this entire network, and this can be kind of like a optional step for your needs. You can put down like a switch node and do this optionally. So first of all, instead of using a Boolean node, let's use a array node. Put it down inside here and connect also both of these inside here. And we're going to have to do a little bit of a conversion for this array node. And for the groups, let's set up our groups. We can actually reuse the Boolean groups inside here. So let's copy our group A, and in this group A is actually going to be our collision. So basically collision, which is normally array a second input, our collision is going to be our single geometry of the loop. So let's say at the loop 0 it's going to be our ID 0 geometry, and for our group that we want to array points is going to be everything but. So let's go ahead to this one. So we have basically inverted these two. You can see we get errors because we do not have a connection between for each block. So select these two and add this per input like that. And let's actually take a look how it actually works. So in this, let's not transform points, turn this off, make sure that it's at the minimum distance instead of project rays. Let's put in a max distance, something like 0.5. That's going to be half a meter. And let's create a point group. Let's call it 2del_pts. And let's actually take a look at this group. Go to the points. So you can see now we have nothing, but let's increase it, and we may be going to be able to see the, actually let's put it to the single path, because okay, so here it is. So this is our group. You can probably see by the look of it which ID is at 0. It's this one. You can see we are starting to select anything around this geometry that is at the let's say 1 meter distance between the points and other geometry. So that's would be only this geometry. So let's actually put it at 0.5. So inside, in this time, it's nothing is going to be done because there isn't any geometry around it. But for other loops, it's going to be. So what we want to do is actually promote this. So for us not to be, so that we don't have to change any of this code, we can just promote this to the group promote. If I could write correctly, okay. So group promote, let's promote our to delete PTs from here to the primitives, and let's call it to del prims. You see, you're going to get an exclamation mark because the primitive group already exists. That's because of the looping of this, and because of the we have actually a group left from our previous loop. And now, even though the group is 0, it still exists. So what we can do is actually, to prepare our geometry with every loop, we actually group delete. Let's group delete a primitive. So we know that incoming this group is going to be deleted, and every time this loop runs, the new group is actually created. So that's for the, I think it's actually still would work, it's just so it doesn't throw up any exclamation marks. And so the prims and for the group is the same, and basically this should already work. Let's try this out on a single pass. Let's go to the array and increase it. So you can see we're actually starting to delete these points around. And put it to 0.5 and turn off the single pass like that. And let's go to this geometry. You can see we have deleted a bunch of geometry that's around each one of these that are closer than 0.5 meters. And if you go to the array, increase it, you can see it becomes sparser and sparser. Now that we are reasonably happy with our scatter, let's actually extract these points and copy the actual geometry. So put down a extract centroid inside here. So we can use the bounding box center, and the piece attribute is going to be ID. That's with the capital letters. ID. So this is basically going to get a center of every one of these. So that's good. And now I want to transfer our attributes from our points before we copy this. So take this from the wrangle where we assign our ID and go to the very bottom of it and put down attribute transfer. And this connect these to here. And now what we're going to do is just transfer these points. And one thing that we're going to have a problem with is the position, because the centroid of this geometry is going to be actually at the middle of this geometry, and if we want to make sure that we copy the same way, we have to basically zero it out at the copy point. So we can actually do this with the allow p attribute, and with the points we want to move the position, want to get normals, want to get ID, we want to get orient, we want to get prop ID, and p scale we don't use, but we can also p scale also. And the tag is used by the scatter and align. We can also maybe also that one too. So if we have done it correctly, these points should get all of the attributes from here, but obviously with only the points that do not intersect with each other. And so put down a copy to points. Connect this here. So for the piece attribute, let's use prop ID. Actually, we don't even need actually the ID of it anymore, because we are going to copy it by prop ID. So go to our real geometry, which is this one, move it to the bottom of it, like this, and make sure that we are instancing the geometry, and we copy it inside here, and actually I get it on target point. Actually it has to be a piece attribute, like that. After merging it all together, we can see the results. And one thing more I want to do is actually put down a switch node. That's a switch node, which is going to basically, we can either bypass or also delete by proximity, depending on our needs. So we can then wrap it all in the HDA. So let's say we want to also delete by proximity, then just change it. If we do not want to, leave it at that. So let's say we do not want to. Let's go and move our boxes, something like this. So you can see it's still pretty, it's not too unresponsive. And that's it for this tutorial. I'm going to try to make them more often now. See you next time.